All right, good. We're live on YouTube too. I'm not gonna forget to hit start stream like I did on Saturday until we're like an hour in. You really can't be asked in the pics. You're just gonna say integral for balance of -1 to 2 of 1 over square root of the absolute value of x dx. You can show if it converges or not. If it does converge, find its value. Yo, AS Gaming Bros, how's it going? Good to see you. Hey, Bode. Yeah, we can definitely do this, Thunder. It nearly called you critical again. Integrate 1 over square root absolute value of x dx from -1 to 2. Hey, Kurt F. Gal, how's it going? Thanks for following 17 hours ago. You need help at AS Gaming Bros? Happy to do that. I'm going to work on this problem from Thunder first, but if you want, feel free to go ahead and post it, and you'll be next. This problem shouldn't take more than a few minutes, I don't think. 1 over root absolute value x dx. That's our problem. All right, so this is one of those sneaky integrals where there's a discontinuity hidden inside of the bounds, because -1 to 2 includes 0, and dividing by 0 is obviously a bad thing. So I usually am lazy and I don't do this, but really the way that you're supposed to do this is you split up into two integrals, and they both involve limits. That's how you deal with a discontinuity. So it'll be the limit as, we can just use any letter we want. T approaches 0 from the left of the integral from -1 to t. Because we can't, like, it's technically not right to actually put a 0 there because it's not defined for 0. Dx plus, and then the limit as, we can reuse t, I think. Well, we shouldn't reuse t. Let's say s. Approaches 0 from the right, same idea of from s to 2, 1 over root absolute value x dx. Now that's a pain to write when you're doing multiple lines of it as part of your work, but like that's the right way to write it. You haven't done from the left or the right things, you just pretended 0. Oh. That's weird. I guess you could pretend it's 0. That's not technically right, but that's gonna change the value for this problem, I think. You have a topic called general solution? Okay, it's Gaming Bros. And banana buter. Smallest n such an n by n table can be covered by the same amount of 2 by 1. Ooh. I'm not sure. I would need to think about that more, but I have this integral I need to work on first, and then a question from AS Gaming Bros. I'll paste that over to the YouTube chat in case, or the Twitch chat in case someone wants to think about it, but I'm not sure I understand what the question is yet. Can be covered by the same, like, I don't know. Oh, I see. AS Gaming Bros. Yeah, you have one of those trig problems. We can do that. Yeah, because that's always like a bit of a weird thing to find the general solutions for those. But looking at this one, I'm just going to go through the pain of writing these limits out each time. So on this first integral, our values are always negative because we're not actually getting to 0. So we're going from -1 and we're approaching 0, we're never quite getting to 0. So this absolute value of x, I guess it's really 1 over root negative x, because that negative will turn the entire thing positive because the input values are always positive. Dx plus, it makes you really comfortable to have a square root of a negative, but I think it's what you're supposed to do here, because we don't know how to integrate an absolute value directly. We have to kind of think about its cases. And over here, x is always positive, so we can say just root x. Hey Stuki. Okay, in banana buter, I have VOD saying that n equals 10. I don't know how, but yeah. It's just this part you're confused on? So it's because of the way the absolute value function works. It looks like a V. Like that. And this component of the line is y equals x, and that component is y equals negative x. And so when our x's range from -1 to 0, we want this component of the absolute value function. And when the x's range from 0 to 2, we want that component on the right. So that's why I put a negative x in there. That's just 5 divides n from the area. Oh, okay. I'll copy paste that over to the YouTube chat in case that helps out Banana. Because I'm not trying to do it for myself, to be honest. It's just that. So yeah, if that makes sense, Thunder, that's all you need to see. I can leave you with that. But if you want to see it done out fully, let me know, I guess. Sounds like you're good? Okay. Okay. All right, so let's go on to AS Gaming Bros question. And the general solution of 5 tan theta equals 4 cosine theta. Oh, okay, I think I see how we do it. It'll be a little bit annoying, but we can do it. Hey Jen, 5 tan theta equals 4 cosine theta. Okay, so when they say general solution, I assume you know kind of why, but just in case you don't, when you have like trig equations like this, trig functions are periodic, so you tend to get infinitely many solutions because, let's just ignore the 5 and the 4. Because they're not going to affect this part of it. You know, tangent looks like that, and it repeats to the left and right infinitely. And then cosine looks like that, off to the left and right. So, and the question asking how many, like, where do these two curves intersect? Because that's where they're equal to each other. So that's why we get infinitely many solutions with these trig equations, as we usually do. The convenient trick we can do, though, is restrict ourselves to just one part of the domain, figure out what it is in there, and then, are we going to add 2 pi or pi? Basically, like, you get all the solutions just in one part, like just in one range of x values, and then whatever you have there, you do plus 2n pi. But sometimes you do plus just n pi if you have tangent, because 2 pi is the period of sine and cosine, just pi is the period of tangent. So I'm not sure which one we're going to need quite yet. And n is just any integer you want. Same note here. Positive or negative. So that's going to be like the general idea that we're going to use here. So let's actually go ahead and solve this. Hey, Quack. A factorial plus b factorial equals 2 to the c factorial? I have no idea how you do that. What is that? What are you supposed to do with that? I'll put it over in the Twitch chat too, in case someone wants to think about it, but like, I don't imagine that's easily solvable. All right, so let's that would kind of lay that groundwork. Let's go about actually trying to solve this for theta. First, I'm gonna notice that tangent is sine over cosine. And now I see we have a cosine theta there, cosine theta there. Let's multiply each side by cosine theta, just get rid of the denominator there. So we get 5 sine theta equals 4 cosine squared theta. And now I'm going to use a Pythagorean identity on that cosine squared because I want everything to be just with one trig function, whether it's tangent, sine, or cosine. And I'm getting led towards wanting to put everything in terms of sine here because that's a cosine squared, and we have this Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. If we have a cosine squared theta, we can subtract sine squared over to the other side in this identity. Get that cosine squared theta equals 1 minus sine squared theta. So let's use this fact right here. Remembering our parentheses. Sine squared theta. All right, so let's multiply that 4 into the parentheses. A and B can't be greater than or equal to 3 at the same time. I assume the factorial's on the C in the exponent. We don't actually know that, I guess. All right, so yeah, Quack, if you're still here, I'll paste over what Bode is saying. Who's much better with these problems than I am. All right, so with this last step, I want everything to be on the same side, so it's equal to 0. So let's add 4 sine squared theta to each side and subtract 4. So we get 4 sine squared theta plus 5 sine theta minus 4 equals 0. Okay? Now, it may not look like it, but this is just, we can solve this just like it's a parabola. If we had 4x squared plus 5x minus 4 equals 0, we can use the same exact things here because we have sine squared sine constant, x squared x constant. So does this factor, like, it multiplies to negative 16 and adds to 5? I don't think so. Let's just do quadratic formula here, I think. So when we do quadratic formula with this, we get sine theta equals to whatever we get from the quadratic formula. Because we don't have x, we have sine theta. So it's minus b plus or minus root b squared minus 4ac. So minus 4 times minus 4 times 4. 4 cubed. 4 times 4 is 16. 16 times 4 is 64. Over 2 times a is 4, so we get 8. What does this come out to be? 89? That's not a nice number. I guess I don't expect a nice number, though. Is 89 prime? I can't think of anything that goes into it. So I don't think root 89 is going to be reducible. Yeah, Quack, Bode is asking where you got that problem from. Similar to one that Bode is seeing. 89 is prime? Okay, thank you, Jed. Oh god, I don't know how to do those problems, Curtis. Yeah, I'm sorry. Is that negative, AS Gaming Bros? Is what negative? I don't think I've made a mistake yet. on the 4 minus 5. Like here? What I did from this step was I added 4 sine squared over here, and I subtracted the 4 over to the left. So the signs here, I think, are all correct, if you're asking about that one. Just want to see other methods? Yeah, I've hardly ever done those problems. So I don't think I've ever done a problem like that, to be honest. So sorry about that. Oh, and Bode, Quack says they think they got it from the Austrian Math Olympiad. You see it's positive? Oh, okay, cool. Hey, Viv. Okay, so this is a really annoying thing we got, unfortunately. I think we can work with it. But we found now that sine theta equals -5 plus root 89 over 8, and that sine theta equals -5 minus root 89 over 8. So we're gonna need to verify this, but let's take the arcsine of each side for these, and then we should get 2 solutions inside the domain of arcsine. And arcsine is the same as inverse sine. I'm just not a fan of this notation, but these do mean the same thing. Okay, so arcsine is defined. Where is arcsine defined? Between minus pi over 2 and plus pi over 2? I'm gonna need to check my answer here, but I think I think all we have to do here is we found 2 solutions between minus pi over 2 and positive pi over 2. And now since we have arcsine, we add the period of sine onto these to get the general solution. So arcsine -5 plus root 89 over 8 plus 2n pi, and theta equals arcsine -5 minus root 89 over 8 plus 2n pi, where n equals -2, -1, 0, 1, 2, ... Let's check this though, because this feels like a very weird answer. Arcsine equals cosecant? Oh no. That's why I hate that notation. Yeah, I'm wondering if we want just k pi Kurtoff-Gell, because we do have a tangent in the original equation. I think because we're using arcsine, though, we do want 2n pi or k pi. It doesn't matter what constant we use. Wolfram, are you disobeying me? There we go. Can you use the first sine inverse the answer of the first sine? I'm not sure if that's what you mean with that, AS Gaming Bros. If you're trying to use... Thanks, Mangoes. I appreciate you. If you're talking about using the first solution to express the second one, like using that first arcsine on the left to somehow express the arcsine on the right, I don't think that's possible. I'm not sure, though, if I'm interpreting you right. You hate it? Oh, what is this? Oh, it's getting it numerically. So 2 pi n, and what are these two numbers? That's what we have to check. And it's going to be 2 times that number. Arc sine -5 plus square root 89 over 8. .58. I think we need, when you multiply this 0.29 by 2, we get the same thing. So if I take this and divide it by 2, 0.2937, 0.2937. Hell yeah. Okay. Let's check the other one with a minus. Oh, what is that? Why is that imaginary? Is arcsine not defined here? Ugh. No. Okay. So I made a mistake with the second. So I verified the first solution with the plus is correct. The second solution is outside the bounds of where arcsine is defined. Can we subtract something to put it in range? Or is it just not a solution? It should be a solution. I think we need to... How do we get... Frick. So I think we can translate this if we subtract the right angle. Or I guess, no, it's not an angle though. It's arcsine of a length. How does that work? No solution? That, I mean, it makes sense, I guess, because sine is restricted between -1 and 1. Yeah. So where does the second solution come from that Wolfram Alpha gets? Is there... Is that like plus pi or something? The first, or like, not, that's definitely not plus pi. 180 minus my positive 1? Oh, maybe that's what AS Gaming Bros was saying. We can, yeah, let's just try that. Arcsine, this thing. Pi minus that. 2.55, we need to divide it by 2. Because of how Wolfram Alpha expressed their answer. 1.277. 1.277. Okay, that's the answer. Why is that? Okay, that's true, yeah. You do deserve a save there, Thunder. Sounds I'm doing it. Let's give one to Stuki as well. All right, so... Oh, is anyone bought down? I wonder. AS Gaming Bros, just to try to... I forget, I remember I learned why we had to do this once, and I forgot. This solution here with the minus, we actually have to throw it out. Because this is not in the range of arcsine, or out of the domain, I guess. You're only allowed to plug in things between -pi/2 and +pi/2 into arcsine. And this is below -pi/2, which you can really only easily verify with the calculator. You can estimate a square root, but it's still kind of a pain. So it's hard to give you like guidance if you're not allowed to use a calculator on that. We do get a second solution if we do theta equals pi minus the plus solution, which might be what you were saying. And I'm trying to remember why. I think when you do these in general, you can potentially get two solutions from each because of this pi minus business. Oh, the commands one still works. The saves does not for some reason. Interesting. And let's look at the graphs of these to maybe figure out why. Oh, yeah. Fenblocks like farms the saves when I do abstract algebra, especially because I make so many stupid mistakes. um, how do you do domain restriction? Minus pi over 2 less than x less than pi over 2. Here we go. Oh, it's some more geometry questions in here. Oh god. I think it's check saves if you want to see the number of saves. Just saves adds a save. Okay. Movie number 5 must be from Legacy. I mean, you had a good few saves because a lot of times when I make stupid mistakes. Okay, so hey Fembox, yeah. um, this is a very weird situation. I don't know how generally applicable. Yeah, AS Gaming Bro, you're right. The second answer we throw out entirely. That's pretty smarter than Austrian mathematicians. um, yeah, I guess it's just that reference angle thing for why we take the first angle and do pi minus that, or 180 degrees minus that. Because I think the first solution we got is this one up here, and the second solution is this one down here. No, maybe it's actually the other way around. Probably is. What was the first time, Viv? Consider the sine graph? Oh, of the like quadratic sine thing that I got? Like y equals 4 sine squared x plus 5 sine x minus 4. This thing? Whoa. Or you're not saying that? It's kind of a cool looking graph though. Right, that's why we do the pi minus that for arcsine. Because it's defined, or sine is defined in all 4 quadrants, arcsine is only defined in 2 quadrants. And you find the one where it's arcsine isn't defined by doing pi minus that. Wait. Y equals sine x. Girdle graphed x squared minus 1 wrong? Oh no. Y equals minus something? Something. I don't know what that's supposed to be. The minus something is my solution. Here? See if it $10. I guess I could do the numerical value. Get rid of the arc sign. Oh, I get what you're saying. What the heck? Oh, because it's over 8. Why is there a minus sign, though? Oh. Oh. That's kind of neat. Just gonna keep on doing this. Even though it's minus pi to pi. Minus pi less than x less than pi. Yeah, AS Gaming Bros. Yeah, we need to find the solutions in the second and third quadrant, and that's how we do it. I'm just kind of playing around with decimals right now, to be honest, but it sounds like you know what to do, which is whenever you take the arc sign, you want to also do pi minus that thing, so you get the second solution in the second or third quadrant. Hey, critical. Oh, I thought you're are you still doing calculus? I thought you just had your final. You want to estimate your final exam score? Uh, I guess so, yeah. More than 100 out of 240? I mean, if you just want to know what the answer is, like, can we just use Wolfram Alpha? Was there anyone else's question that I was missing? Banana got helped, Quack got helped. I don't think there's anyone else. I'm from America, at Abdella. I'm in California. You actually see the problems? I guess feel free to post some. The meantime, I'll go erase the whiteboard. Yeah, it's gamers. Let me know if you need anything else. I guess before I erase it. You're gonna do it. Oh, all right. See you then. Critical. You're from Morocco. Oh, cool, Abdella. Welcome in. I'm not gonna do this one. Someone posted a question to my Discord. Oops. I don't know how legible it's gonna be on stream. Actually, I can't really zoom in on Discord. Oh, this is like a. Yeah, I doubt I can do this one. Oh, if you want to explain something more, AS Gaming Bros, I'm happy to do it. Okay, reversing the order of the coefficients, which I really don't know how you do this. Saying x to the 2024 makes you think it's competition, and I really can't do competition math. Like, thanks for the work, Thunder. Even just in general, trying to name a polynomial or two polynomials that multiply to x to the 2024 plus 1, like, I don't know how you, like, I feel like I've tried to do a problem like that before, and it's really hard because of that plus 1. So I know if someone wants to take a whack at it, they can try, but I don't think I can. Then roots of unity. I mean, I don't know how to do that, but it's just an example. There's no way they're going to be degree 3 if you need to make 2024. Okay, let me go erase the whiteboard. Hey, syntax error. How's it going? Depends on the problem. Syntax error. People would ask me a bunch of problems that I just have no business being able to do. So differential equation. Sure. Is it for fun or do you need help with it? Oh, I'm so sorry if has my audio been doubled? Uh, when my mic died on Saturday, I added in my other mic right here, and I forgot to remove it. So I hope my... Yeah, sorry about that. I said two mics picking my voice. I guess it wasn't sync, yeah. I guess it didn't sound that bad though. You know, solution you don't know how to get it. One plus y prime squared equals y times y double. That's non-linear. I guess we can think about it. Abdullah, no, I'm not. I'm a math tutor, although right now I'm not doing much actual tutoring besides this stream. Now I'm looking at my audio loops and I feel like I'm missing something. Oh, I know why it feels like that, because I just mess with my audio setup in general. Okay. I have not solved very many nonlinear differential equations that aren't separable. um, oh, and see abode. Good luck with the geography. I assume there's some clever sub there. You get Kosh. Huh. Still doing catenary stuff. Oh yeah. Oh yeah. You asked about the mode a long time ago, right? I mean, I can Google and see if we can find a solution. I doubt I'll be able to figure this out on my own though. What's happening here? Is this like... Is the quotient rule with this? Does it come out to be this? That's kind of crazy if it does. Oh, that's what they're explaining right here. Oops. Oh wait, no. They're just noticing this. 1 over y squared is equal to y prime over y prime. Wait, how does this equal that? You must use some facts from the equation up here. Oh, I get it. What? How? I would never think to do this. What the hell? You just... You pull that out of your ass. And then you notice that you have a y double prime y minus y prime squared, which matches with this equation up here. And you can say that this thing equals 1 because of that differential equation. Dude, that is... Completing the square for lunatics? I guess? Yeah, if you want to, I'll link you. I would not have gotten this on my own. All right. I don't want politics in my YouTube chat or my Twitch chat. Okay. He says he's wrong. Welcome back, Fembox. When you write z prime equals 1 over y squared, you would differentiate with respect to x, but then you integrate with respect to y. Hmm. What? What is this? Hey, thanks, Fembox. I have a really hard time coming up with good ideas for emotes. There's been a saying it is right. I don't know. Weird. It's not the same problem. That's the same problem. Yeah, me neither, syntax error. This technique with letting y prime equal p, where p is a function of y, is a little crazy. It's probably allowed. Wait, when you take y prime equals p and you differentiate with respect to y again, where p is a function of y. Why is it p prime times p? Is that how the chain rule works there? That doesn't make any sense to me. I don't know how I would use the chain rule. This is a weird thing. It's almost like yeah, I don't know. Oh, I mean, this is just the initial post. Maybe I should read the actual answers. I'm not sure if this helps. You got the right. Yeah, I feel like I can't contribute anything intelligent to this problem. I'm sorry. I can't even understand these solutions, to be honest. So, I mean, I can link this one too, but it's a very weird differential equation. Like this solution technique, I know you have to do something weird to solve a differential equation like this, but yeah. Yeah, I really like differential equations. These weird ones I'm not as much of a fan of, but I really like the applications that differential equations have. And if you did have something that was like this hard to solve, you probably just would do it numerically, I feel like. Well, I mean, I guess this one isn't like that hard to solve, if like it's not that long of a problem, but just do it numerically, I guess. Not be too proud about it. I might do, to fill in some time, we might do some abstract algebra. Where did I leave off the last time I was doing it? Okay, questions 1 through 6, I think I did. Oh god. Euler-Lagrangian. What is the Euler-Lagrangian? Did I just type a differential equation? Hey Sharda, how's it going? Yeah, I haven't seen this before. Calculus of variation, minimize a functional. Oh, okay. Yeah, I have done nothing with calculus of variations before. I remember which one I did. I definitely did 8. Did I do 9? Welcome in then, Sharda. I feel like I maybe did this one verbally, but I don't remember what the answer was, so let's just take a look at 9 again. My subgroup does z sub 20 have? It has a subgroup for each divisor of 20. So 1, 2, 4, 5. Why can't I do math? 10 and 20? So 6, I guess. So generated for each of these subgroups, it's just the numbers that I just said. Figured out that for ropes, gravity takes all the energy it can, so the shape of the rope such that the arc length between them is a constant. Flex Cheeks, thanks for the follow. Yeah, sure, that's what I'm working on now. Better be blueberry waffles. I just love the way that he says that line. I'm making waffles. Suppose. Oh, I'll be live for at least another hour, Flex Cheeks, probably longer. What type of math are you doing? 8 hours a day for the past week? Oh, geez. Welcome to the club. Suppose that G is generated by A and that the order of A is 20. Yeah, Flex Cheeks, once you're done with your break, which please do take as much time as you need, feel free to post a question there in chat or in my Discord. Let me know what class you're in though, just so I make sure I don't like waste your time. Because if you're in some class that it's pre-calc, oh, okay, cool. I can definitely help with that. Yeah, I can absolutely help with like pre-calc questions like that. And if you're new to the Twitch like math help community, let me shout out a bunch of other math streamers. Yeah, thanks, Jed. So all people on that list can absolutely help you with questions as well. So if I'm ever not around and you have a question, I'd highly recommend you honestly just follow them all. Oh, that's right. Yeah, Penbox does tutoring. It's a good way to get 8 hours a day in. But yeah, the Discord makes it easy to like post screenshots and stuff too, if you prefer that to typing it out. Welcome back, AS Gaming Bros. How many subgroups does G have? This is like, I feel like for all these questions, they're like really hamming it up with the relationship between Z20 and a generic cyclic group of order 20. So G is kind of the same number of subgroups as Z20, which I think I said was 6. And the generators are a to the 1, a squared, a to the 4th, a to the 5th, a to the 10th, a to the 20. Well, a to the 20 is not a... Yes, it is. Because that's just the trivial subgroup. Okay. Uh, 13 to 15. And at 13. Someone say dollar central. Yeah. It's actually called that. Find a generator for in Z24, find a generator for subgroup generated by 21 intersect subgroup generated by 10. Interesting. So what subgroup does 21 generate? It generates the same subgroup as the GCD of 24, 21. Some good flex. See you then. The GCD of 21 and 24 is 3. So a to the 21, or sorry, the subgroup generated by 21 is equal to subgroup generated by 3. And for 10, it's going to be equal to subgroup generated by 2. So the intersection of 3 and 2 is going to be multiples of 6. So 6, 12, 18, 24, which comes out to be 0. I should actually write this down, I feel like. The answer order 20 is 1. I'm pretty sure there are 6 subgroups for 9. It's 1 for each divisor of 20. Okay, this one I'm going to stop being quite as lazy as I've been and actually write this one out on the board. We have Z24. We have the subgroup generated by 21 intersect the subgroup generated by 10. This is the same thing as subgroup generated by 3 intersect the subgroup generated by 2. And that's the same as the subgroup generated by 6. So we get 6, 12, 18, and 24, which is 0. And 0 is the identity. That's my logic there. And then, wait. Suppose the order of A is 24. Are we given that that A is a generator itself, though? Is A a member of Z24, or is A a member of a generic cyclic group? Or does it matter? It probably doesn't matter what the group group that A is a part of doesn't even have to be cyclic because we're talking about like subgroups that are cyclic. Yeah, okay. I think I can buy that. See, if the order of A is 24, we can do the exact same thing. A to the 21 intersect A to the 10, right? That's equal to A cubed intersect A squared, which is equal to A to the 6. So we get A to the 6, A to the 12, A to the 18, and E. And so for the general, if you have A to the M intersect A to the N, that's equal to subgroup generated by GCD and, oh, well, we're not given the order of the entire, well, the order of A. Okay, yeah. Order of A, comma, M, plus, or no, times. Comma, N. That's what I would say. Can you give advice for NEET exam? I don't know what that is, Sharda. This is 13. I want to verify my answer for 13 here. The back of the book. Because I have been known to go off the rails and say absolutely bonkers stuff. This is page 109. I'm going to guess the answers on like 550. No? That's hamming. The LCM of the GCDs. Ooh. You might be right there, Padrig, if I'm saying that right. Yeah, because what happens if we are given two things that aren't relatively prime? If we were given, say, 10 and 15. Oh, yeah, you're right. We do need the... Yeah. Because they were nice and gave us 21 and 10, which are relatively prime. But if we were given A to the 10 intersect A to the 15, my thing here would give you A to the 25, which is the same thing as A. But it doesn't generate the entire group. It's like what I wrote here. It's not right. It should actually be A to the 5th in the taking the LCM of these two numbers would fix that. This is a very long expression here, but I guess we'll write it. Here we go. Chapter 13, keep going up. So chapter 4, number 13, scroll up so I can't see 15. Okay, I'm just gonna let it be cut off. A is the LCM of m comma n mod 24. I feel like what I wrote is equivalent. If you mod it 24, maybe it's not equivalent. Is it? Okay. Hey, Hardlocked, we're mathing. Hope things are good for you. K is the LCM of m times n mod 24. Or m comma n mod 24. Does the GCD accomplish the same thing as mod 24? New update. Oh, hardlocked, absolutely. When is that? Let me see if I can find it quick. I don't see a recent announcement on the Steam page. But no, yeah, I've been wanting to get some Phasma again. If there's a new update soon, then all the better. Okay, so I'm still thinking about this. Is mod 24 equivalent to the GCD in this case? We mod out by 24, so that's represented in the usual. Sharda, I said I don't know what a NEAT exam is. I've never heard of that. It comes with a new map. Ooh, oh, it's gonna be the lighthouse. Oh, that's gonna be awesome. Phasmophobia update. Wonder if I can see. Okay. I don't know when it's going to be, but that's going to be awesome if they're doing the lighthouse. Yeah, Padrig, that's probably a more elegant way to do it with if you do mod 24. I'm trying to come up with an example that would break what I wrote, and I haven't been able to do it. I don't know. To me, the GCD thing is more like natural, but it might be wrong for some case that I can't think of right now. All right, so that's 13. We're doing 13 through 15. All right, so let's work on 14. Suppose a cyclic group G has exactly 3 subgroups. G itself, E, and a subgroup of order 7. What is the order of G? I assume 49. That's just an instinct right now, and I'm trying to justify it, though. Because if it was, I think it needs to be a power of 7, because a cyclic group has one subgroup for each divisor. So if you had 7 cubed, you would have another subgroup for 7. No, 7 squared doesn't divide. Wait, yes, it does. Yeah, okay. So it has to be exactly 7 squared and not like any power of 7, I think. We can say if 7 is replaced with p, where p is a prime. Well, then the order of g is p squared, I guess. You're in class 12 grade, how to do physics to score good marks. I'm not the best with physics, Sharda. I would say with most things like that, though, it's just a lot of practice, unfortunately. I have to keep on doing problems until it sinks in eventually. It's not a very satisfying answer, but that's the only one that I've been able to find. Okay. It's a neat problem. So let's look at 15. Oops, 15. Let G be abelian and let H be all G that belongs to G such that the order of G divides 12. Prove H is a subgroup of G. The order of G divides 12. So we're taking all elements with orders 1, 2, 3, 4, 6, and 12. No way, right? Well, maybe the abelian will save it. I'm worried about closure because G is just an arbitrary group. So if H includes like G to the 12, it must include G to the 24, right? But 24 doesn't divide 12. Woohoo, hey! How's it been? So what's the subgroup test again? We prove that it's closed, and we prove that it has inverses. And that's all we have to do. I'm doing good too. Thanks for asking. That thing that you sent me was kind of interesting. Like I assume that little painter person was the person who made some of those paintings or something, but and not empty $10, right? I almost kind of wonder what was like happening in that video. I guess let's just start trying to do things with this problem. And hopefully it'll come to us as we work on it. Let's do green. G is abelian. H equals all G in G such that the order of G divides 12. Okay. I wanted to write the order of G divides 12. That'd be really confusing notation though. Goodbye, eraser. Okay, so I can definitely see how we prove that E is an H. E belongs to G. The order of E is 1. 1 divides 12. So E, that's not E. Well, it is if you're Greek, I guess. So E belongs to H. Okay. So now we have to prove closure, which is the part that I'm concerned about. I'm not sure that I fully believe that it's closed. So our usual thing is what we do, let A and B belong to H. And we need to look at what AB is. We need to prove that the order of A times B divides 12. So the order of A divides 12. The order of B divides 12. Don't we have... Don't we have something with the order of two things being multiplied? There's like a theorem that's relevant here, I think. The order of GH yeah, well, let me see where I can find that theorem in the books. I think we had a theorem like that somewhere. And this chapter had about 1 million theorems, and I want to make sure that I'm keeping track of them. Ah, if A and B belong to a finite group, oh, we're not given a finite. Well, can we say that H is finite? I assume H has to be finite. Then AB, the order of AB divides the order of A times the order of B. Because that's where we use the abelionosity. I think it's the technical term. All right. So the order of A times the order of B wouldn't we say it divides 12 squared? Like at worst, I guess. I hate this divides notation, I'm going to be honest. I'm not used to using it. If the order of A divides 12, that means that the order of A times some number equals 12, and the order of B times some other number equals 12. And if we multiply A times B, 144 over km? I don't really know how to make sense of that. I do know how to make sense of needing to use the bathroom, though, and I kind of need to use the bathroom. I'll be right back, guys. Okay. Sorry about that. Drake says, look at GH to the power of LCM m comma n. Oh, we're saying that m and n are the orders of G and H. Did I? I guess I did, yeah. You can also just look at it as the kernel homomorphism G to G12. Oh yeah, I haven't gotten there quite yet, but this book seems to do a good job of building up to bigger concepts. Sorry, yeah, exactly, Nikas. And actually, yeah, hey, welcome in, Padraig. B, just explain what's going on a bit. I do like these math help live streams, but when things aren't, or when there's a question from chat, I do some studying. And so right now I'm looking at an abstract algebra textbook. I'm on chapter 4 about cyclic groups in this book here. And this abstract algebra reading group is being run by another streamer over on Twitch called Penn Center. I don't know. Oh, shoot. What is my YouTube command for this? Is it math streamers? Let's see if that works. Okay, yeah. So Penn Center, the last one on the list, is the one who's running this reading group. Oh, over on YouTube, the commands are different. Yeah. Because the Enigma bot isn't on YouTube, so. Actually, wait, that was Nightbot. Did I not set that up with? Okay, dude, my commands are all over the place. Especially StreamerBot. I worked on it a bit when I first installed it, and I stopped working on it because it didn't do everything that I thought it did. Anyway, let me go back to what you're suggesting here. We're going to let the order of G and let the order of H be M and N respectively. So GH to the power of their LCM. How do we know their LCM divides 12? How do we know it's not more than 12? Actually, they would multiply to 12, right? Unless they're the same number. That's fair, Padraig, yeah. I was worried about like 12 and 12, but their LCM was just 12, so I guess that fixes it. Okay, that's a good argument, I guess. Yeah. I should maybe get new ink in the screen marker. It feels like it's a little light. Let's go back to using black. The order of A equals M. In the order of B equals N. So M divides 12 and N divides 12. Consider AB to the power of LCM m comma n, which by abelian we can say is a to the LCM m comma n b LCM m comma n. And it's still a multiple of its order. Oh, you should abbreviate it with saying something, yeah. Like I want to say that the LCM of m comma n is a multiple of m. Which I guess, okay, yeah, we can say that exactly. LCM of m comma n is equal to some multiple of m, which is equal to some other multiple of n, right? So a to the LCM of m comma n is equal to a to the km, we could say, and b to the ln, which is a to the k, a to the m, which is just, e to the k, e to the l, which is just e. Which implies the order of a, b this is the tricky part. It's not necessarily the LCM of m comma n. It is potentially a factor, or like, you know, so like something that can multiply to the LCM. How do we say that? It's not k times the, like, or it's not some number times the LCM. It's the LCM divided by some number. That makes it, but we have to keep it an integer. I have the idea here, I just am struggling with the notation, I guess. We could say the order of AB divides the LCM, maybe. M comma n. That's how we get around this, I think. And the order of the LCM of, or sorry, and the LCM of m comma n divides 12. So AB also divides 12. And AB is an H. Okay. The order of a, right, yeah, okay. Okay, so that's the closure part. That's really weird that it's closed. It feels like it shouldn't be, but we just showed it is. We need to show inverses now. So what we know about if A is order m, the order of A inverse is also m. Oh, well, that's easy, isn't it then? Here is A is m, then the order of A inverse is also m. M divides 12, so A inverse is an H. And that means that H is a subgroup of G. Next on the list from Penn Center is 18. So let A be a group element in the order of A be infinity. Complete the following statement. The order of A to the I equals the order of A to the J if and only if. Ooh. Is it possible to have a finite subgroup of an infinite group? Or I guess the order of A is infinity. I feel like this is always true if it's infinite order. But what's a counterexample if it's not? Just think about it. The order of A to the I equals the order of A to the J. Because if you think about like calculating subgroup by hand, or like a cyclic subgroup by hand, you start with A to the I, and then you go A to the 2i, A to the 3i, A to the 4i. No, wait. Ugh. Yes, it is like that. And you're never going to get back to the identity, which I feel like would mean A to the I is going to be infinite order too, and A to the J is going to be infinite order. I struggle to find a case where this isn't true, I guess. Oh, it's an even number problem, so I can't even check the answer. All right, let's go back up through some of the theorems. Because this is very related to, I think, a few of the corollaries in different situations. It is so... Well, never mind. The order of A to the n equals 1 if n equals 0. Oh. Zero is something we have to be careful of. That's the only time you can get a finite. Yeah. Okay, because I was thinking about just Z under addition. That's the only infinite cyclic group that they've discussed in this chapter. So to complete the statement then, if and only if either I equals j equals 0, or I doesn't equal 0 and j doesn't equal 0. Other than that, we're good. Okay, I should I was thinking about negative numbers, but those are fine too. I didn't even think to try 0. Good call there. Okay, 19 is next. Cyclic group has an element of infinite order. How many elements of finite order does it have? I want to say 1, which is E, because of what we just said. Yeah, it's got to be just one element of finite order. Yeah, I guess so. 22 is next. A group of order 3 must be cyclic. Okay. Interesting. Oh, we can use inverses here. Well, yeah, we can use inverses here because if, okay, yeah, because the order of each element has to be 1 or it has to be 1. Or sorry, 3 or it has to divide 3. Let G equals E, A, B. So we want to prove that this thing is cyclic. So we need to find a generator for it. Can I ask, do you have Lagrange's theorem and Cauchy's theorem? I think we have neither. Lagrange's theorem, we definitely don't. Cauchy's theorem, I don't think we do. Or if we have, it's not by that name. The order of G is 3. Since the order of an element must divide. Ooh. We only used that property for cyclic groups, didn't we? We're trying to prove that it's cyclic. Do we know? That would be a Lagrange's theorem thing, isn't it? Which we don't have yet. We don't have Cauchy yet, but we're getting very close. Okay. So maybe it's not going to be as easy as I thought, because we've only been given so far that oh, maybe we can use this. Because we've only been given that the order of each element must divide the order of the entire group in the context of a cyclic group, I think. And we're trying to prove that it is cyclic, so we can't use anything of that yet. Unfortunately. It'd make it very easy if we could. I think we can use the Euler phi function, though. How does that work? No, that applies to cyclic. Wait, no. Wait, so I was thinking about AB Padraig. But the issue is, I don't know how we distinguish. Well, like I assume the point is that it's going to equal E, in that B is going to be equal to A inverse. I don't know how to justify that though. I'm worried about the case if A is its own inverse and B is also its own inverse. I assume that can't be possible because A and B would be order 2 then, and we can't have order 2. If AB equals A, oh, we could eliminate everything else. That's neat. Hey, Sherlock. Yeah, what's up? Okay. This is 22. I'm going to work through this problem, Sherlock, but... we look at your question after. Okay. If AB equals A, then B equals E, which is a contradiction. Because B has to be distinct from E. If AB equals B, then A equals E, which is a contradiction. So, AB equals E. B is equal to A inverse, and A is equal to B inverse, I think is what we want. I mean, I don't know if that's the most important thing, but... do we have enough information now to look at the subgroup generated by A? Very problem-solving questions. Yeah, who needs theorems, exactly. A squared. Well, so what is A squared here? We should... That's not quite right, is it? We want to... What does this mean? We want to somehow show that a squared equals b, right? So if we take this and we left multiply by a, that's not right. A squared equals e? I'm missing something here. The scalar equation... Ooh, I wanted to ask for the notation there for a minute. Yeah, that's what I'm trying to go for, Padraig, but I'm getting mixed up on the mechanics of this. Like... What I would have proved just here, if a squared is e, is that g is not cyclic, at least with a. What can we say about a squared? That's what we need to do here. Like we can take that left multiply by a to get a squared b equals a, right multiply by b, get a squared equals ab inverse. I'm just getting back to a squared equals e though, that doesn't make any sense. A is a to the 1, e is a to the 0, b is a inverse. Well, isn't a supposed to be order 3? That's what I'm getting tripped up on. Like, I'm getting that a is order 2, but we would want here is a squared e, right? It's just that a squared is already e, and that's where I'm getting confused. Hmm. How come you think a squared equals e? Actually, I guess that's not e, is it? Like, I want to get that a squared equals b, I guess is what I really want. And I then know people that we've shown the group is cyclic, but what can we say about AB inverse, I guess? I'm so close. Maybe a squared isn't e, but I mean, can we let a squared be e and show a contradiction? I think there should be a direct way to prove it, just like starting from ab equals e and doing some manipulations. Hmm. Is there a contradiction if a squared is e? And sorry, Sherlock, this problem was taking longer than I thought it would. The scalar equation given this vector equation. I'm gonna try to keep thinking about this algebra one, but I don't want to keep you waiting for much longer here. Writing a scalar, I haven't heard of, like, it might just be the notation of how it's impossible to write vectors and stuff in Twitch chat. Get the scalar equation given this vector equation. I just want to see if I can find like an example of it with the proper formatting. Oh, does this define a plane? Oh, it does. Okay. Are you still here, by the way, Sherlock? I would understand if you left. I'll type in chat too in case you maybe have the stream on mute. So yeah, this is like the y-intercept. Or not the y, like the when everything is 0. Starting point. Then you take the cross product of these two vectors to get your normal vector, which become your coefficients for the plane. All right, so until Sherlock pops back up in chat, let's keep thinking about this. This must imply that b is a squared. How do I close that gap? If ab is equal to e, then B is A's inverse. B equals A inverse. The inverse of A can't be E. The inverse of A can't be A? Can we justify that? Well, that seems... Well... Okay, that's where I was trying to get to, I guess, Trig. And A squared not equal to A, I think that's just supposed to be obvious, right? Like, we don't need to justify that. Because that's only true if A is equal to E, if A squared equals A. Okay. Okay. I think that's how we do it. Thank you for that. A squared is not equal to E. Because A is not equal to A inverse because B is A inverse. Oops, B is A inverse. Maybe it's a convoluted way of saying that, but yeah. And A squared is not equal to A, obviously. No, that's I don't just say obviously. I'll say A is not E. So A squared equals B, and the subgroup generated by A is A, B, E. So A generates E. Okay. E. A generates G. There you go. Thank you for that, Padrig. Yes, Suki, I assume these are all transposed. Oh, Sherlock, are you back now? I think I know how to do this. Let me rewrite the problem that you wrote on the board, just to make sure that we're on the same page, though. That I'm, like, formatting it right, because it's really hard to type vectors and stuff in chat, so... You have X, Y, Z. 375 plus S 121 plus T 123. Is this right? Okay, cool. No, you don't have to do it again. Like, you just can't write that vertical vector in Twitch chat. So let's all on the same page now. So yeah, the idea is, I mean, I don't know if this is the part that you're stuck on, but the idea is that the two vectors with the s's and the t's make a plane. And the first vector, 3, 7, 5, is like an offset, like how it's almost like a y-intercept for a line y equals mx plus b. It's kind of like how up or down that plane starts. The actual shape of the plane is determined by s and t because the vectors with s and t, because those are attached to the variables. And the process here is a plane is defined, a plane in scalar form is defined by a normal vector and a starting point. And the starting point is kind of given to us with 3, 7, 5. But we need to figure out what that normal vector is. And the important realization is that 1, 2, 1 and 1, 2, 3 are both parallel to the plane. And there's a really convenient way to get a vector that is perpendicular to two other vectors, which is the cross product. So we want to find the cross product of 1, 2, 1 and 1, 2, 3 and use that to figure out what our plane is. So let's start doing that. One, 2, 1 cross 1, 2, 3 is equal to the determinant of the matrix with I, J, K, then these coefficients in a row, then these coefficients in a row. So give this determinant, I'm going to eliminate along the top row, because when you do the cross product, you always want to do I, J, and K. So when we take out the column with I, we get 2, 1, 2, 3, I, minus, now we do J, so 1, 1, 1, 3, J, plus, now with K, 1, 2, 1, 2, now we have a bunch of 2 by 2 determinants to find. So we do AD minus BC, 6 minus 2I, minus 3 minus 1J, plus, I feel like it's going to be 0. 2 minus 2, it is 0, okay. 6 minus 2 is 4. 3 minus 1 is 2. And then 2 minus 2 is 0. So the K vector drops off completely, and that's okay. So our perpendicular, really? Is that okay that we're getting a two-dimensional vector? That feels wrong. Oh, is it going to be parallel to, or it's going to be true for all z, I guess, which is a little bit weird. The equation for a plane, you may have learned it in like a slightly different way. But the way that I usually use is a times x minus x naught plus b y minus y naught plus c z minus z naught equals 0, where a, b, and c are the components of this normal vector. And I'm getting confused because one of the components is 0 for c, and I think that's okay. Okay, that one works too. Let's use that form instead. It comes out to be the same thing, but we'll use the way that you're used to. So yeah, ax plus by plus c equals 0. Ax plus by, I assume plus c times z plus d equals 0. And yeah, a, b, and c are the components of this vector. So we should verify, I want to verify this to make sure. that we're getting the right answer here, but A is 4. X is the starting point for X, which is 3. B is negative 2. Y is the Y component there, which is 7. Now C is 0, which is the sketchy part. Z is 5, but that's not going to matter. Then D is what we want to solve for. No, you're completely fine, Sherlock. Don't worry about it. So 4 times 3 is 12. Negative 2 times 7 is negative 14. Plus D equals 0. So that's what? Negative 2 plus D equals 0. So D equals 2. So we get, since D equals 2, let's plug back in up here, but we're going to keep X, Y, and Z as variables. Oh my God, 4A, 4X, B is negative 2. Y plus 0Z plus 2 equals 0. But, you know, 0Z is just 0, so it's 4x minus 2y plus 2 equals 0, which is really just a two-dimensional function, but it is defined for all z, and that's what I want to investigate a bit more. It technically still is a plane if you're thinking three-dimensionally. So I go to a 3D grapher, and I give it this two-dimensional line, 4x minus 2y plus 2 equals 0. Oh, it's still graphing. Extend to... Okay, so before I go to off the rails, on the bottom is the xy plane, and that's just a normal, like, line in the xy space. But if we're thinking in 3 dimensions, this is true for any value of z. So we're going to extend this line, you know, both up with the positive z and down with the negative z. So when I do this, we get like a sheet of paper. Well, I get any plane is a sheet of paper, I guess, but like, what I want to do here is I guess I want to plot our vectors that go with the variables. 1, 2, I don't think Desmos will do it as a vector, but 1, 2, 3. Oh, of course. Okay. This answer makes sense. Okay, so all this time doing with this was just to verify that I didn't do something terribly wrong. And I think I haven't done anything terribly wrong. I think you can take the answer that I wrote at the bottom there as good. We are supposed to get just a two-dimensional, you know, a seemingly two-dimensional equation here with just x and y, because our initial two starting vectors, which these are just points, have the exact same x and y component. And it's a little bit hard to see when I don't think Desmos will draw them as an arrow. I wonder, if I gave it square brackets, what would Desmos think? It would hate it. It would think I'm stupid. Okay, that's cool. And the offset isn't quite right because we are given that like a starting point as well. I'm trying to figure out good way of phrasing this, and it's failing me, but Viv, I think I, probably be, add the word history onto that. Seems like a bad call for branding to name my channel that. Oh, Senny, thank you so much for the raid. Holy crap. Not even playing DayZ. I'm checking to make sure I'm in the right category, right? Yeah. Regardless, thank you so much for the raid. I hope your run was good. Paintera, hey, yeah, we're doing math. Quickness, Eddie, hey. Wow, I wasn't expecting that. If anyone was hanging out here before, please go check out Senny. She plays DayZ and she's awesome. And Joe. Thank you so much for the raid too, Joe. Bronk, love this nerd shit? Hell yeah. Pro hate nerd. I'll take it. Yeah, for anyone who's new here, I do these math streams, and I also play DayZ at least once a week. But yeah, today's a math day, so we're just looking at a problem from Sherlock in chat involving we're given this like vector equation here, and you can find that the vector equation like this can also be defined with scalar numbers, which are just numbers that we're normally used to that aren't vectors, and they just kind of form a plane. So we're going from this vector form to an equivalent scalar form, which I haven't done in a while, but I got a kind of a weird answer, and we were just like verifying it with this graph here. And I think I got to the right answer. Thank you both so much. I forget the name of the map that you two are playing. Something with A, but a land or something. Forgot it too. Yeah. The director, I found your stream through Senny. I've been watching some of your math streams. You suck at math. Your niece has a PhD in math? Oh, well, welcome in. Thanks so much for saying hi. And a star. That does have like the most A's. Yeah, what DayZ map has the most A's? Azalea has what, like 3 A's? And a star has 4. It's a whole bunch of them. Either way, I really appreciate it. Geez, actually, you know what? I should take this opportunity. There are more math streamers out there than just me. So if anyone is on any chance interested in math streams, there's a whole bunch of streamers that I can recommend highly as well. This map is Ayland. This map is not Ayland. These words don't fit anymore. Antarctica? There's an Alaska map, I think. So many A maps. Yeah, Sherlock, I'm sorry that there's a whole like flood in chat there, but if you are still around, let me know if there's anything that you want to hear more about this problem. If not, I'll probably move on to something else. Yeah, thanks again. I don't know like what to say, but I really appreciate that raid, even though I wasn't even playing DayZ, but thanks so much. Oh yeah, sure. It's more effort to learn math more. Um, yeah, I mean, I think it's fun just to learn for the sake of learning it, but there's definitely some things that I just don't enjoy all that much. I should give a little plug because I don't know like what your experience with math is, Crow, but there's going to be 3 courses on math taught on Twitch over the summer or the fall. All right, see here, Sherlock. Thanks for the question. So going to be like undergraduate math level courses. I think they're all going to be built towards people who have had maybe 1 semester of calculus. There's going to be a class on complex variables, which is like imaginary numbers taught by Penn Center, and that's starting like July 6th or something pretty soon. There's going to be a class in the fall. I don't know if dates are set on infinite series, which is it's going to be taught as more like a real analysis thing, which is like the proofs behind calculus. Taught by Zach or E to the 2i pi. And I think the date is to be determined, but N-Simplex Pachinko, aka Obi-Wan, is going to be doing a differential equations class. Kernel's pretty basic. Yeah. And Pantera. Yes. Oh, yeah. That is the From Mars to Sirius album. Oh, my God. The perspective is hard. Yeah, that's a From Mars to Sirius album. But behind me there. I keep on meaning to ask you about your username because it looks like Pantera, but also with paint. So do you like Pantera and also paint? For all A and R, let there be. But yeah, I think the one, if you haven't taken a calculus class, I think Penn Center's complex variables class, it might even require calculus for the first part. And also people are welcome to lurk on that stuff too, not like be that much of a participant if you don't feel comfortable. Pantera's already gone? Oh, okay. Pantera fan and also a masochist. Yeah, Fembox is shouting out that I'm doing this like physics reading group on electricity and magnetism. Yeah, oh, Pantera. I read as paint, but no, yeah, Pantera. Oh, and sorry, Amorphous, over in the YouTube chat. I saw you wrote something, but I was a little bit distracted. If you have a question, please feel free to type it. But yeah, I'm doing this reading group on physics. It's pretty heavy in the calculus, but on electricity and magnetism. It's been a lot of fun, but it's like some multivariable calculus class that even I've been struggling with. I haven't heard of Pain, the band. Peter, I don't even know how to pronounce that, Crow. Fun in a painful way. Finish this book. You can quantize electromagnetism. Oh yeah, they even talk about that there with quantum electrodynamics, which, I mean, it'd be cool to actually say that I've learned quantum theory in some way, but I don't know if I'll be able to get through even the regular electricity and magnetism, so I don't want to bite off more than I can chew yet. But just for this, I was doing some abstract algebra studying too, which is another thing that Penn Center is doing. It'd be cool to do some physics though, I guess. Maybe switch gears. It's yeah, for those who are new around here, these streams are normally like me taking questions from chat, but especially with summer getting here and just in general, there aren't always questions to answer in chat. So I fill in that downtime with usually either just chatting with people or doing some self-study stuff. So it's mostly been abstract algebra and this electricity and magnetism stuff. This was drawing pictures that turn out to be diverging integrals. Okay. I can handle that, I guess. Gotta scroll all the way down here. Okay. Oh, we have Amorphous over in the YouTube chat putting a question in. Find the smallest positive number r with the property given differentiable functions f, g from r to r1. Oh god, what is this? This is an analysis problem that you and your friends are doing. Oh, from r to r1, find, I guess prove f of 0 is greater than 0? Or is that, those are the 5 properties? Oh, find the smallest number r with a given property. Okay. Hey, Lila Cubed. Oh, cool. Yeah, it's been, I mean, I'm only on chapter 1. I'm a little bit afraid it's going to be too hard for me the further we go. But I'm really enjoying the problems that we've done so far. Is this, Amorphous, is the problem just for fun? Or are you asking to, like, for help with it? I'm basing over in the Twitch chat if someone wants to see it. Oops, I didn't copy the entire question, though. I know a little bit of analysis as well. If it's just for fun, I might not do this one. You usually see me doing math. Yeah, I've been doing this physics like studying too, because I think, I don't know, they just you get some interesting math in it. Gaming by Faro, thanks for the follow. So I can try and think about this problem that you posted, but it's going to be really at the edges of my knowledge here. Let me take the physics away for a second. Find the smallest positive number r with the property given differential functions f, g from r to r. Yeah. You love math, my concentration, not so much. Yeah, that's fair, gaming. Or Faro. God, I like, especially when I'm streaming it, it's so hard to just like talk about one thing at a time. Or even just like just think about one thing at a time. But also just, even when I do math on my own, it's really easy to get distracted. I guess I can even do this little thing. Just get it on the screen there. The smallest positive number r with these properties. The only time r is actually used is that in property 3, f of r is equal to 0. So we have f of 0 is greater than 0, g of 0 is 0, f of r is 0, and we have to find r. The absolute value of f prime x is less than or equal to the absolute value of g of x. The absolute value of g prime of x is less than or equal to the absolute value of f. God, I don't even know where to start with this. What is those last two properties are really confusing to unpack. Does that mean f and g? I'm thinking about like y-intercepts here for f and g in relation to those last two properties. You're gonna guess pi over 2? Is that based on anything, or are you just guessing? These are practicing problems to prepare for a Caltech application. I'm not applying to Caltech, but you're so excited by that green cover. Oh, cool. And sorry, I know it's addressed to Defendbox fan, but it's part of a reading group that I've been doing. So each Saturday we get together and kind of solve some of the problems from the book as a group. It only just started, and it's open to everyone. And sometimes during the downtime of these streams, I'll just like go through and choose a problem or two to just like do. Um, I stream at 1 p.m. Pacific time, which is basically 3 hours ago in your time zone, because it's nearly 4 p.m. for me. It's camp on 2 a.m. already. All right, Crow. Thanks so much for lurking. Yeah, please do get some sleep. Appreciate you coming along for the raid. Amorphous. There's a lot going on with this problem. And yeah, sorry for anyone who's listening on Twitch. I dual stream to YouTube and Twitch, so I'm talking to someone in the YouTube chat with this part right now. There's just a lot to unpack with these 5 properties, and I feel like I haven't done an analysis problem that's like quite this complex before. Your guess is based on sine and cosine. Do sine and cosine, I guess what you're taking f equals to cosine and g equals to sine. And so f prime is negative sine, which is less than or equal to sine, well, the absolute value, yeah. Okay. Sine and cosine would fit the bill. Amorphous, you agree with the person who said that? You're thinking the same thing. Okay. Oh, okay, so it's coming up with an example and getting the r in that situation. And pi over 2 is the smallest positive number r such that cosine of r equals 0. Okay. And so maybe the task is to try to come up with a different example, or see if we can come up with a different example that gets there sooner. And why can't we arbitrarily scale sine and cosine? Like, what about sine x over x and cosine x over x? Or cosine x minus 1 over x, or whatever it'd have to be. Because, like, you wouldn't have to do over x. We could just do, like, a 5th of each, or a 10th of each, or a 100th of each. Well, I guess it'd be sine of 1/10 x, or cosine of a 10th, or just like trying to shrink it horizontally. Why can't we do that and get arbitrarily close to 0? I feel like we wouldn't be violating any of these conditions. Let's try it. Dang it. Fenlox, I want you to just give me the answer so I don't have to think too hard. Okay, so we're saying, let's just do it in Desmos so I can be at least a little bit lazy. We're saying that f of x is cosine of x in our base example. Yeah, I know. It's just, this stream is really just me stalling until someone gives me the answer. We're gonna make the claim that these functions fit the bill. And I'm just gonna say that they do. And if we took a 5th of each, I don't know my stretch and transform rules. So if we take 5 times each x, mean value theorem, Padraig says. Is it mean value theorem? That could be it. We've now gotten closer to 0. And I feel like we're not violating any of the conditions here. Our rules 4 and 5, well, f prime x is minus 5 sine 5x, right? And g prime x is, I think we are? Maybe because of this. Oh! F prime gets stretched vertically, while g is staying the same. And f prime has to be less than g, and that's not always true. Okay. Good call, Fembox. Yeah, so we can't scale sine and cosine. I think at all, because we just violated property 4, and if we try to stretch them instead of shrink them, I think we would violate property 5. Okay. Frickin' chain rule. You can squash them vertically. Ooh, we can. Well, I don't know if that would help. The zeros are still the same. We could squash them vertically. We don't get any closer to 0 than pi over 2, though. So it's not a significant difference for this problem. Mean value theorem seems like it could be helpful here. Differentiating one of those last two rules. What do you differentiate? I guess if they're both positive from 0 to pi over 2, you don't have to go to the absolute value. The inequalities don't necessarily hold up, though, do they? Maybe you can say they do for sine and cosine. I don't know what... I don't know what that would help with, I guess, Fembox. Oh my god, my headphone cord like slid against my chair and it made a super deep noise in my ear. It scared me. Yeah, and I don't know, like, I don't know. So I feel like what we've just determined is that with trig, I mean, I guess we haven't considered, like, well, we wouldn't consider cosecant cotangent and those like 1 over things. Tangents, well, okay, yeah. The only trig functions we can consider are sine and cosine, because those are the only ones that map R to R. Everything else has discontinuities. So I think it's settled for trig functions, and we need to consider maybe any other type of functions, like would exponential. Hey, Brian. Work on the problem that's just above there. It's an analysis one from a someone over in the YouTube chat. We've gotten or I say we, but Penbox has gotten a tentative answer pi over 2 if we take f and g as shown on Desmos here. And I think no other trig functions are possible, even if you were to scale sine and cosine. And I'm trying to figure out if any other function can potentially do this too. Yeah, so all 5 properties have to be true. And we're naming the R in property 3, the smallest R in property 3 that we possibly can, I guess. So like, would polynomials ever behave like this? Polynomials never can, because f of 0, or no. There should be a reason we can eliminate like polynomials, logs, exponents. Is there any other type of function we want to worry about? I'm trying to think of like, you know, normal non-exotic functions here. F equals 0. Oh, yeah. That, I mean, true, Fenbox. They do have to map R to R, which I think helps eliminate stuff that's too crazy, like the gamma function. I'm just thinking we can be like decent. I mean, it's an analysis class. We probably shouldn't like. I guess there's compositions. Okay, no. Maybe eliminating the other possibilities isn't good. I don't know. Does the person on YouTube know the answer? No, they said that they and their friends have been doing it, but it's hard. So it sounds like they haven't gotten the answer. We could Google it. I'm probably gonna find this exact problem. Oh well. It might be these like the special characters that are messing it up. This is not AP Calc. I think it's Google's just doing weird stuff because it doesn't like, or it's really hard to Google math problems. It'll get things that are kind of, it's the way the keywords searches work, I guess. I always have a hard time finding my exact problem. But yeah, no, I did like the calculus BC test, which granted it was like 10 years ago, which I don't like thinking about too hard. And we never had to do anything this hard. Yeah. I think it was just a completely unrelated, way easier problem. Oh, really? They're not supposed to be on the internet? Collegeboard.org, that sounds familiar. Like, aren't those people who run the AP test? Huh. Yeah, I don't know. G and any subsequent words was ignored because we limit queries to... No, yeah, I know it's not AP. I'm not sure I know what else to tell you though, Amorphous. I'm sorry. Like, I'm having a time coming up with any ideas on my own, to be honest. Sending materials on the internet. Yeah, like, I remember having to leave my phone. Or I think I had to leave my phone like in my locker or something. Like you couldn't even have it in your pocket, I don't think. Um, yeah, Amorphs. I think I might need to. Like, I don't think I have anything else that I can say about your problem that's helpful, unfortunately. Pi over 2 or 3 pi over 2. Yeah, I can't come up with a better example than that. That's what I've been trying to do, and I haven't been able to get any closer. But yeah, I'm kind of out of ideas on that one, so I'm sorry about that. I think I might just switch over to physics again. Properties 4 and 5 check me up. Yeah, it's super weird because it's really good to prove that pi over 2 is the best solution. Yeah, exactly. And blocks like I don't even know how you'd begin to do that. It's an interesting one, and I don't know like who I could like potentially ask. Like Zach would be my best bet, but he actually just went on vacation, I think, and even then, I don't know how he would feel about this problem. The random AP calculus practice. Honestly, that's honestly not a bad idea, but I've been kind of excited to do physics, and in particular, I've been thinking about this hole in a plane problem for a while. It does feel like a differential equations problem in disguise. Ooh. Oh. That is an interesting idea. I don't quite know how we would use it exactly. But that is like an interesting way of like framing it. But I kind of want to take a look at this problem. So I remember seeing it a few like 2 weeks ago or something. I've been like wanting to do it ever since. I need some views. Though I'm very lucky and I got a double raid from Senny and Joe, who both stream DayZ, which I really appreciate. Yeah, they it's not like math, which is like blown the heck up, but yeah, I was lucky to get raids from some cool people, I guess. Try and find the solution. Yeah, if you do find the solution, it'd be interesting to see it amorphous. Yeah, because I bet I could understand the solution. Getting the solution on my own is I'm not very optimistic about that. Yeah, please do. And if I'm not sure if you're in my Discord or not, but if you get it at any time, you can like post it there in my Discord too if you want, or if you just want to wait until you see me live again. I'm happy to. That's like fine too. I'm magnetic, apparently. All right, so this hole in a plane problem. A hole of radius r is cut out from a very large flat sheet with uniform charge density sigma. Let L be the line perpendicular to the sheet passing through the center of the hole. What is the electric field at a point on L at distance z from the center of the hole. And they're saying to use some symmetry here with making the plane equal to concentric rings, which I think is a neat idea, because I normally think of a plane as a square, but of course it's infinite, and you can use any shape that covers the entire square, or rectangle, I guess, which a ring can do. This problem has some junk in its trunk. Scale, I don't know if that's readable, but I'll just leave it like that. Let's do black. The choice of marker color is really important here. It's readable? Okay, thank you, Fembox. Hole of radius r is cut out from the plane. So this plane, which is very infinite and not at all just a random square that I drew, has a hole in it. That hole is radius big R. And L is the line perpendicular to the sheet passing through the center of the hole. Not just infinite, very infinite. Yeah, Blatwy. That's a level above uncountably infinite. So L is the name of the line, which is kind of weird, but distance, like I'd rather just call it the distance Z. That's a weird Z. You're getting erased, Z. Okay. Let's just say, like, that's our point there. I'll be the line. Okay, so I assume we can make the claim that the portion of the electric field parallel to the plane is 0 because everything cancels out in the exact middle. So we only have to worry about perpendicular field. And if we, what do we want to do? I guess we want to draw an arbitrary ring. And work out what the impact of just this ring is. That's a really weird ring. I drew that terribly, but why is your gut telling you the answer will be independent of R? That would be a cool thing to find. And I mean, for a normal plane that with no hole cut in it, it certainly is independent of R. Or sorry, oh no, independent of big R. That I'm not so sure of. Oh, I mean, maybe that too. Huh. Yeah, I don't know. It might just be, it could just be the, dude, it'd be cool if it's the same as the equation for a normal plane with no hole. Because it is infinite. But yeah, I'm not sure. So we can call, I guess that will be little r. This has thickness dr. So the area of this ring, or you know, a small difference in the area of the ring is going to be the circumference of the circle, 2 pi r, times the small thickness of dr. I think that's reasonable to say. Hey, Cosmolano. It's the divergence of V equals rho. We haven't done anything with divergence yet. There probably is a simple solution like that, though. dq is equal to sigma dA, which is equal to sigma 2 pi r dr. I'm trying to do this with a Coulomb's law, I guess. It's to make a differential like that. Looks like wizardry. I'm more or less mirroring what the book has done to make rings in other situations, so I'm just not questioning it that much. Ooh, tried to sneeze there. Thankfully I got my mute in. Is this wizardry? Okay, so the electric field, I guess we can say perpendicular, is, or a differential electric field that's perpendicular is equal to dq over 4 pi epsilon naught distance. What is the distance? We never worked that out. We have the same issue where I'm using R too many times. What am I going to call the distance, like, from there to there? Too many radii. We can call it the square root of r squared plus z squared. That's what we can call it. And we square it when we come over to this formula, so r squared plus z squared. Times... I want to just slam a cosine theta on this. What am I defining theta to be, though? Yeah, where do I put my theta? Because we definitely have to integrate, like, around... Call it D? That's true. Yeah. Oh, yeah. Welcome in, Copper. Am I still having my copy-paste? Yeah, I do. I think the fact that you need a z over root what I wrote. Really? Oh, for like this factor on the side here? Yeah, that would be... If theta's that angle right there, we would want sine of that angle. Theta. And we're not going to need theta again, because we can integrate just in terms of small r. Like, we've already built our theta into the 2 pi r dr. dd over dd. Oh, God. I think I have something that I can work with here. Do we need to get rid of z? Z is just a constant. I feel like I can just integrate this. Integral from big R to infinity. dq we said is sigma 2 pi r dr over 4 pi epsilon naught r squared plus z squared times z over root r squared plus z squared. I think we can just integrate this. Expression for any point z. Well, I think we're keeping z fixed. Like, this should work for any z, what I've done, I think. Yeah. Tuning back in. We've covered a lot of ground. Yes, Dookie. It's been a journey. Yeah, I think we're okay. Take the constants out. Pi cancels. Sigma z 2 epsilon naught. R to infinity. What do we have? We have r over r squared plus z squared squared to the 3 over 2 dr. We have a pretty easy u sub here, which is u equals r squared plus z squared. Du is 2r dr. Sigma z, I'll change that to 4 epsilon naught. R to, oh, no, different bounds, which I'm just going to ignore. 1 over u to the 3 over 2 du. Sigma z over 4 epsilon naught. That's u to the minus 3 over 2, which integrates to... Ugh, that's a weird... Negative 2u to the minus a half? I guess, yeah. For whatever reason, I just don't like how that looks, but I think that's the integral. Minus 2 r squared plus z squared r to infinity. All right. You can come out front, I guess. That's not good. Oh, minus a half. I forgot the exponent. Oops. It was like, why is that diverging? The first term is 0. Good, the negative signs are going to go away. We can express r in terms of z or something, I'm sure. So sigma z over 2 epsilon naught root r squared plus z squared. And can we get rid of that big R squared? I guess we don't actually have to. We're given big R as part of the problem. Hey, Phobos. So much for your theory of independent of R. I mean, assuming I'm right, I guess, yeah. I want to check the answer in the back of the book, but I don't want to accidentally see the answer for B and C, so let's just plow through. If R approaches infinity, E approaches 0. Oh yeah, that is a nice way of checking. And if Z approaches infinity, you still get something. You also do I was thinking that anything parallel to the plane should cancel out. Why do we? With the way that we've constructed these rings. So we only need to worry about E perpendicular. The other component is 0. If z goes to infinity, oh, it becomes just the normal thing for a plane. Oh, that's kind of neat. The farther away you get, the less the whole matters. That sounds weird. I want to make sure that is the equation for a normal plane if z goes to infinity, because that's kind of cool. Oh, what the frick did I do? I tried to scroll and zoom out at the same time. Sigma over 2 epsilon naught? Okay, that's kind of cool. For an infinite sheet without a hole in it. Okay. Not convinced the perpendicular, well, parallel, I guess, but really, so I'm thinking if you take 2 points on the opposite end of each ring, we can draw this out. I was thinking that if that's your ring there, and if you look just at like that strip and the strip directly across from it, and you're going right to the center, like surely these things are going to cancel out for parallel. The perpendicular parts are going to add because they go in the same direction. But the parallel shouldn't. That was my rationale there, Bradley. Oh, I covered it up. Just because you're doing a master's in physics doesn't mean you're good at it. Oh no. It's fair. I literally named myself Dundas Math, and I'm kind of terrible at math, so I can't judge. But yeah, so that was basically my entire thought process to why the parallel component should cancel. And I think for a normal, like for a normal plane without a hole in it, the parallel component is 0. Maybe the ring changes something, but yeah, the line is centered. We're not doing it at an arbitrary point. Okay, cool. Yeah, if it wasn't centered, we'd definitely be in trouble. Hire me. Okay, so let's look at part B. The charge minus Q with mass M is released from rest on L, very close to the center of the hole. Show that it undergoes oh no, another oscillatory motion one. Ugh. Get ready to throw everything that we don't like. Find the frequency omega of these oscillations. Simple harmonic. Oh, okay. I mean, were you thinking of this one or are you thinking of 8? Because 8, we talked a lot about. This is, I guess, an evolution of 8, to be honest. But I don't know. Honestly, all I looked at was like part A when I was looking at this problem. I didn't actually see that part B would be simple harmonic motion. You're thinking of this one? Okay. The charge minus Q. We're not given that the charge density is positive or negative. Oh, and Copper says the solution is pi over 2 to amorphous problem. It's a pretty famous problem on TikTok, but it first appeared on a Putnam 2023 exam. Oh, interesting. So, Fedbox, you're right about that analysis problem, according to Copper, at least. Thanks for looking into it, Copper. I'll copy paste what Copper actually wrote to the Twitch chat, too. And solution is pi over 2. Okay, so yeah, we're going to look at it for a specific value of Q and sigma. The charge density is negative, the frequency is imaginary? Ooh. Okay. I haven't gotten that far yet. Oh, I guess, yeah, you do get a square root when you do simple harmonic motion for, like, the frequency, right? If a charge minus Q with mass M is released from rest on L, very close to the center of the hole, show that undergoes oscillatory motion. Okay, so it's being attracted to the hole, which I think is something we can all sympathize with. Is it easier? I think it's the same logic. Don't be dirty. Shouldn't have watched me play Played Up last week then. Well, actually, I guess you probably didn't, but yeah, things are getting a little dirty there. Where you have E equals F of Z. Oh, true. Is that true? I mean, yeah, we can definitely get the force. We have the field, so we can get the force of any arbitrary particle we want. Or charge. Taylor expand the force and show there's a linear term. Right. And that's where we're going to use the very close to the center of the hole. To get rid of the higher power terms. So, okay, I might be going off the rails here. Where am I going to put this? I might need to erase what I just wrote, because I don't have enough room on my whiteboard. I could do this. Chop off part A. We're done with part A. So if the field is that, the force is the field times our charge minus Q. Sigma Z minus Q over 2 epsilon naught R squared plus Z squared. And we know that force is equal to mass times acceleration. And I think we need to work out if do we have to integrate this twice to get the position? Or what's actually happening here? No, I think I'm making it too complicated. Because simple harmonic motion is F equals kx. So do we just need an approximation for this thing here? Is there a convenient pre-made Taylor series for this? Because yeah, I think we already have the equation for force. We just need to get the Taylor series. It's a binomial expansion if that's easier. Ugh, it's annoying. We can do it. I mean, if we only show it as a linear term, can we just get the first, like, 3 terms of the Taylor series? You only need the first 2 terms? Yeah, I think a Taylor series won't be that bad to do. And we're centering it about 0, I guess. So the first term is 0 because it's just this thing. Z is our variable, R is a constant. So we plug in the 0 for Z plus, then what is it? F prime 1 or F prime 0 over 1 factorial times X. So what is oh god, that's a quotient rule. Ugh. A lot of this will be less ugly once we plug in 0 for Z. Okay, this entire thing on the right goes to 0. That's just R on top. R over R squared equals 1 over R. And I want to make sure I'm not misremembering my Taylor series formula. Only check it's to be degenerate. Take the Z out of the function. Oh, that would have made it a bit easier, wouldn't it? Integrating twice? I don't think we're integrating twice. I think we want to stick with or we don't even need to consider, I don't know. I sent the link. Oh yeah, Copper. I don't think YouTube lets you send links. Can you say like the title of the video or something to Google, I guess? Sorry, I missed that part in chat. Okay, yeah, so I did get the formula for the first 2 terms right. You can't just integrate twice to solve it, because Z is a function of T. Well, yeah, I mean, integrating twice would get us position, but if we want to prove simple harmonic motion, we want to show the force that we already have. That's not F. Oh, did I cover up the problem? No, I'm good. We want to show that F is equal to some constant times X, or in this case, we're saying Z. And if we use this approximation here, then we're already in business. This K is just an arbitrary constant, not anything special. Minus sigma Q for 2 epsilon naught R times Z. All of these are constants, the Z is our variable. I think that's, we need to find the period of it, or the frequency. Integrating twice to find Z. I'm not sure I follow you, Fembox. I feel like we don't have to do an actual integral on this ugly thing. I think it's just omega is the square root of this constant, or with ignoring the negative sign. Yeah, I'm definitely gonna check the answer in the back of the book. Copper, you can't easily send a link in YouTube. You'd have to put the title of the video in chat or something that we can Google on our own. I don't think it's possible for me to let you put a link in YouTube chat. What is omega if n is 1? So what I said sigma q. Sigma is 10 to the minus 6. Q is minus 10 to the minus 8. Doesn't that minus, oh no, minus Q is that. And we already accounted for the minus sign, so let's not take the square root of a negative number over 2 epsilon naught r. What's the value of epsilon naught? 0.1 times 2 times epsilon naught, wherever epsilon naught is. Here it is. 8.854 times 10 to the negative 12. 8.854 times 10 to the minus 12. What number do we get here? 0.075. I think it'd be hertz. I don't remember, to be honest. I'm not good with basically anything in physics besides this one very narrow thing that I'm starting to not be completely useless at. Radians per second? Okay. Wait, this is chapter 2. 55 maybe? Okay, that gets us closer. Ugh. Here we go. What's part C? If I just assume that I'm right, because I'm always right. The charge minus q with mass m is released from rest on L, a distance z from the sheet. What is its speed when it passes through the center of the hole? What is your answer reduced to for large z? Your idea is atrocious and doesn't work? Yeah, if you were to try to actually integrate that twice, I don't think you'd even get what you want, but it'd be kind of terrible. Because simple harmonic motion is based on the force, not the position. Well, I mean, you probably could express with position too, but yeah. The charge minus q, and I'm talking about this like I know everything about it, and I really don't. I'm just going off the little bit that I do know. With, okay. What is its speed when it passes through the center of the hole? So this seems like it's an integration problem, though. Because we're going to integrate the force function that we just found from z to 0, use the simple harmonic motion approximation. Or they're saying for large z, and this approximation was for small z. the integral is not going to be, it's just a u sub. I don't know. Maybe we can just use the approximation, but if we have to consider a large z, the integral isn't so bad to do once. That I think we could do it. I might regret it, but let's just try it. If I do end up regretting it, then you were right, Blackley, but if we were to say acceleration is minus sigma z q over 2 epsilon naught root r squared plus z squared, and we want to get to velocity when it's at the center. I hope that I'm remembering my calculus right, and that we want to say v is the integral from z to 0 of that thing. I think I'm good, yeah. And this is a u sub, which is why I'm not so afraid of doing it. Minus sigma q over 2 epsilon naught 1 over root u du for 2 epsilon naught 2 root r squared plus z squared evaluated from z to 0. We're gonna get a nice cancellation with the minus signs, I think. That's a weird sigma, oh my god. 2r minus 2 root 2z, right? Well, maybe that's not so good. I don't know how to interpret what I just got. The problem is it's dz. It's not dz, it's dt. Well, for simple harmonic motion, those two things are related. My integral, I mean, I'm just kind of generally thinking that velocity is, you derive velocity to get acceleration, so you can integrate acceleration to get velocity. And if your acceleration depends on position, you could also find your velocity in terms of position. And we're interested in what the velocity is when we're at position 0, and we started at z. Fembox, for the work I did for part B, I found a Taylor series approximation for z over root r squared plus z squared. I stopped after getting the second term, which is linear, because anything after that will have z squared or more. And if z is small, we're just going to chop off a small thing squared, I guess. So I got 1 over r times z. I use this approximation up here, and then I'm just kind of vaguely going off memory that the frequency is the square root of the coefficient without the negative sign. Differentiate. What is my answer reduced to for large z or small r? Well, okay, what is doing the simple harmonic motion approximation change for us then? I think we still have the same issue, don't we? I forgot my M, which is a very small issue, but it is an issue. I feel like that needs an M as well. I don't know where it comes from though, to be honest. I feel like the book somehow got an M in there by saying it's equal to MA. I'm getting... I want to look at the answer in the... HMS cosine and sine as the solutions. Yeah. So I think it's cheaty answer time. 665. Tweets, thanks for the follow. Answers, boo. Wow. You know, you're not carrying me through this problem, and I'm not confident enough to do math on my own, so. What else am I to do? Oh, you're 777? Hell yeah. Dude, you gotta buy a lottery ticket. Ooh. Are these figures related to the one we just did? Maybe not. Okay, we got the right answer for part A. See, they do get the M in there. Like, Q sigma over 2 pi, or 2 epsilon naught, MR. They get a differential equation. Buy a lottery ticket for me. You're in... Oh, does Utah not have a lottery? Yeah, sure. I'll definitely split it and not keep it. Forgot the M. Yeah, that's right. I guess that makes sense. Is it like, is it harder to buy alcohol too? Like, you not do it on Sundays maybe? I need to know why the book does this stuff that they do. No fun here. It seems like there's some cool like parks and stuff, but I never been to Utah myself. Buy beer on Sundays, just not liquor. Oh, okay. Two point one 8.85 times 10 to the minus 12. 2.4. Why do I get a different answer in Wolfram? I don't know why my answer here is different. There's a 10 to the minus 3 on the bottom that I forgot somewhere. What? What? That's what you think I wanted to do, Wolfram? Yeah. 8.85. Does that fix it? 2.34. Okay, cool. So, okay, that's not the important part, though. The important part is the setup up here. So, minus QE force equals mass times acceleration, z double dot, which I guess gives us a differential equation, z double prime yeah, because this was negative, but you added it over. This equation represents simple harmonic motion. Really? It did it a completely different way in another problem. I need to know more about simple harmonic motion, I guess. I mean, I guess it's like the same idea, but like, I don't know. So this is a differential equation in terms of t, I guess. Or with respect to t. Oh, bam, we're not using the approximation here for part C. But I didn't even think about potential energy? Why do we care about potential energy? Oh! Because it equals kinetic energy when it's at the center. My integral kind of stupidly came out to be the same thing, though, didn't it? No, not quite. How is theirs different? Oh, my integral is the same, I think, nearly. I just, I messed up my plugging in. I plugged in that z for that r, and that's certainly, I used z twice. That's probably what confused me. I'm using z both as a variable and as a bound for the integral. I should have done z prime like the book did. But that 0 gets plugged into that z. That z gets plugged into that z. Which is, I guess, what confused me. I can factor the 2 out. And now my result matches, I think. At least this matches with that. Wait, so the thing I did was find a potential energy? I integrated force over distance. God, okay, why do we... You were right. Yeah. I need to pay more attention that... Or what I did, it was helpful, but I interpreted it wrong. the thing that I thought I could do is only true for when we're integrating in time, like, which is exactly what you said. And I integrated with distance, which gives you potential energy, which is still helpful because you can equate it to kinetic energy. And just solve that for V. And you still don't have to worry about getting things in terms of time, thankfully. Okay. For large Z, this reduces to Y. Say what? Sorry, I should probably zoom in. If Z is very big, oh, and oh, there's the Z there. I see. Yeah. I missed that there's a Z here. I was like, how is it constant? But no, if you have the square root of something squared, the R squared hardly even matters. So you just end up with a linear term, basically. For large G, the magnitude of the force arising from the field in equation 12.32. Yeah, that's what we said before. Okay. V equals root 2 AZ. The standard one-dimensional kinematic result of V equals root 2 AZ. What? I assume that comes from this sort of thing. Okay. What's up, Amorphous? Oh shoot, Flex, you posted a problem in the Discord? Are you here? I completely missed that. That's a neat problem, though. I'm gonna want to go through and work on Flex's problem, but I want to give him a minute to essentially tune into this. Actually, we can bring Flex's problem up now and start thinking about it. Determine which of the following functions, if any, are the same. Ooh. Huh. Yeah, Amorphous, please do. You can put in like the math discussion channel, I guess. I'm inclined to agree, Penbox. F is definitely not going to be the same. I haven't quite done the math for G and H, but there's no two that could be the same. Awesome. All right, so yeah, Flex, I'm sorry that I missed your problem. If it was a problem in my Discord, that is a good place to do it, but it's good to like let me know in chat that you did it, because I'm not always good about checking my Discord on stream. Find the Taylor series and see if they're equal. Of course, why do we? Ugh, I'm gonna spray this thing. Okay. So we have f of x as 64 to the x plus 13. G of x is 3 to the 6x plus 6. H is 729 times 729 to the x. Cool. All right, so Flex, when I see a problem like this, I kind of interpret it as just kind of play around with these functions and see if there's anything you can do to make them look the same. And when I say play around with the functions, I mean start applying exponent identities. And since you mentioned that you're kind of rusty on math, I'll write the most important exponent identities up on the board here. So if you have, oh gosh, there's many things that we could start with. Or, if we have a to the x in parentheses to the y like this, these exponents multiply, so you get a to the x times y. If you have a to the x times a to the y, in this situation the exponents add, so you get a to the x plus y. I don't think we'll need it here, but there's another identity where if you have a times b in parentheses to the x, you can like distribute this exponent to each one and say a to the x, b to the x. So off the top of my head, those are the most important kind of exponent identities that I can think of. And thinking about these, I only really see stuff that is that direct to do with g of x, because we have 6x plus 6, and that kind of fits the form of this addition identity and then this multiplication identity. So let's choose g of x and just start playing around with it. 3 to the 6x plus 6. So the first thing I'm going to do is notice we have addition here in the exponent, which matches the right side of the identity in the middle here. So we can rewrite this as 3 to the first thing, 6x, times 3 to the second thing, which is just 6. And then we need to figure out what 3 to the 6 is. I think that's work for a calculator, personally. Which I'll do quickly here. 3 to the 6 is 729, which, how convenient, we're starting to match up with h, but let's not get too hasty. So 3 to the 6x, that 3 to the 6 becomes 729. Now we just want to figure out, we still have an identity we can use on this piece here because we have multiplication in the exponent, and we know to deal with multiplication of an exponent too, which is this situation right here. So I'm going to rewrite 3 to the 6x as 3 to the 6 in parentheses to the x. And I could have done 3 to the x to the 6, like that's also true, but it's not helpful here. So That's in where if you practice these enough, it's a pattern that you'll kind of see. But we know what 3 to the 6 is. We just said it's 729. So let's reuse that work. 729 to the x times 729. And wouldn't you know it, that matches exactly with this, because it doesn't matter what order we write things in for multiplication. So I could even rewrite this as that. And the parentheses aren't important either. They don't affect the value of the problem now. So I'd say that g of x and h of x are the same. F of x, because of that plus 13 that's stuck onto the end there, I don't think we're ever going to get anything that's like g of x or h of x. None of the exponent identities will allow us to get like we would never get like a +2 with no exponent out there. It's just not going to happen. So we're not at risk of there being some kind of hidden thing that'll get us to the plus 13. So I'd say just g of x and h of x are the same, and f of x is different. Let me know if you have any questions about that. Or if there's something you want to like hear more about. We can even graph these too. If you want to be a little bit extra. Yeah, it's I have the exact same experience where it's one thing to be told what the rules are. It's another thing entirely to apply them without someone else showing you how to apply them. Oh. Wait, what? Oh, Desmos, stop. Stop. Thank you. There we go. So yeah, the red line is the 64x plus 13. It's different, whereas these blue and green lines are like overlapping with each other. So that's another way that you can like verify these graphically. It's just the same line. Do you know any sites where I can practice problems? I haven't really tried it myself, but I think Khan Academy would have some practice problems. The one I usually suggest more is this Paul's Online Notes. There should be a section on this, yeah. So the site is more focused on calculus, but there are these pretty helpful algebra and trig sections. They're not quite as good as the calculus section, but this is like the other thing that comes to mind for me. These aren't exactly like the ones that you were doing though. Yeah, I mean, I wish it was better, but that's like my default recommendation. It's not as good as it could be though. I'm trying to think of something else that I can think of. Yeah, off the top of my head, I'm not sure. I think it's actually, I just discovered last night there's a little section. It's like other resources. It's like, what's up with this site? Ooh. 5 days to learn the rest of pre-calc? Oh, geez. Uh, well, I mean, I'm not gonna be streaming for a ton longer today, but if you have more questions, let me know. The next time I'll be streaming math is on Thursday. I start like 4 hours and 15 minutes ago. But I think everyone in that list that other math streamers that I sent you before, they can absolutely help you with pre-calc questions. And I'm trying to think, and like there'll be at least one of us streaming basically each day of the week. We don't always do math help in all our streams. So like tonight, I'm not sure there's going to be a math streamer on later after I end, but like tomorrow there'll be like a Ian Stuckey, Actual Education, maybe Dan or Danny Highway. Yeah, it's a really cool community. Oh, you know what? Someone wasn't included in that list is Phobos. That's another person who can definitely help you with these too. Oh god, I have to watch a TikTok. Oh, awesome, Phobos. Yeah, no, Flex Cheeks in chat was just working on pre-calc, and I guess has 5 days until their test. So, I was just trying to recommend math streamers I can think of. I realize I forgot to link your chat, so or your channel. This site isn't perfect either. It's just at UT Austin. Oh, okay. I mean, good luck with that. Yeah, I'm sorry. I don't have a better resource that I could like link you to read on your own. Like, math, exponential, equations, practice. Can we just like find one? Ooh, hey, these don't look too. These look like they might be relevant to applying exponential identities. Some logarithms probably involved too. These images on up to the right are kind of strange. I don't think they have anything to do with math. Plus equals 1 plus 1 equals across. Caveman plus caveman equals business caveman. Some weird like infinite craft stuff here. It's like solid math to you. Wait, blue and orange don't even make green. What is this? And it switched directions. Okay, I don't trust their images. They probably give good practice problems though. Okay, this equation here, that at least is reasonable. Hat plus hat, I mean, well, there's no person, I guess. But like, at least it's 2 hats on top of each other. That's reasonable. Never made the opposite flag green before? Well, I'm just like, isn't it blue and yellow that makes green? I don't know. You see NCR in the back? Yeah. Fallout New Vegas is my favorite game. Snake plus upside down snake is 2-headed snake? Okay, that one I like. You see this stuff in string theory all the time. Oh, this one disturbs me. Why are they conjoined? Okay. Ew, I don't like looking at that last one. I mean, I don't like looking at any of these, to be honest. Okay. Anyway. Yeah, if you have anything else, Flex Cheeks, please let me know. But Amorphous linked to TikTok. Oops. And if I can make it work, I guess I'll watch it. I kind of hate TikTok and everything it stands for, but it's for the sake of math. What? Drag? Oh my god, this is a cute dog. Oh, I hate this. Yeah. Get on with it. I hate this. I hate watching this. I feel like I'm being destroyed on the inside. Okay, so you just guess that it is cosine and sine. You can't like show it. They're doing a proof by contradiction? Oh, I need to see the actual solution. I'm not doing this based off a TikTok video. Uh, was it Putnam 2023? Aha, here we go. Okay. We got a 1 out of 10? Yeah, we did. Get this TikTok off my freaking screen. Apparently it is, yeah. So, Amorphous, you were saying, sort of lucky by guessing cosine x and sine x. Yeah, I think properties 4 and 5 are just intentionally a little bit weird to make you think there are more possible answers, or to make you have to check there are more possible answers. With sine and cosine, they really are just equal to each other. Explain the second solution with fundamental theorem of calculus was your other question. Let's look at the second solution then. As in the first solution, we may assume fx greater than 0 for x between 0 and r. Sure. Okay, so... Wait, what? Oh, yeah, Stuki. I mean, I'll just shout them out till I'm blue in the face, because I do really like their streams and hang out in their chats a lot. But I got rated from Daisy streamers, actually, Senny and Joe. How do you justify... Oh, I didn't spot the absolute value bars on the inside. Okay. Yeah, that's just an identity for integrals. Oh, dude, that's trippy. So Amorphous, are you still watching? Sorry, because I know it took a long time to get to this solution. I think I understand what's happening with these inequalities up here, at least. I mean, I'll type to you on Discord too, in case. Oh, you are watching. Okay, cool, cool, cool. So was it those, or are you asking about like this part in particular, or is it further down? Oh, okay, cool, cool. Yeah, that's completely fine if you don't got other stuff. I just want to make sure that I type back to you if you're not watching. Or are you asking about like something further down in the second solution? So what we found? We found that absolute value of f prime x is less than or equal to the integral of the absolute value. You don't like these solutions, Bladway? This statement here seems a little bit sketchy. Dropping the absolute value bars. We know it's always positive. Okay, yeah, it's always positive, f of x. Okay, that's fine. Oh, Obi! Thank you so much for the raid. Well, welcome in. I hope your stream was good. I guess we even found the solutions. Yeah. How's it going, Obi? I really appreciate that. Did it happen twice? I don't think so. What we're doing right now is looking at the solution to a Putnam problem. Oh, I can actually... How long is this solution? Oh my god. Oh no, I think it just ends... Well, yeah, I think it ends. Right there. Just try seeing chat window. Oh, okay. And in my chat window is just once, at least. So let me get the actual problem up. Apparently this problem here was on a Putnam 2023 exam. And this A3 problem has apparently become a TikTok trend for some reason. So I'm trying to go through a solution for it and explain it to Amorphous over in the YouTube chat. Get our desks and chairs tomorrow? You have something on the floor? Oh, that's hype. Awesome. So yeah, I'm about to switch back to the solution, but if you want to see the problem statement, take a screenshot of it or something, I guess. How much of your stuff have you gotten over to your new place yet? Or like, are you still waiting for a lot more stuff after this? Hey, Waffle. Okay, yeah, so let's go back to the solution. Is this Victor Lee of Lee Group fame? Sorry, I gotta... Or is that just... Harmonic analysis? None. Maybe it's not the same person. Okay. Some people are strangely nice to being hella uncomfortable. Yeah, it gets uncomfortable quick, but for a minute, it can help. Add on our person on the plane, things that ship on the plane of us, including our computers. Oh, okay, cool. I guess so. Why do we? I mean, I never knew what Lee's first name is, so I just saw the last name. I was like, oh, is that the Lee? But I think it's a different Lee. Maybe even lie, because they might pronounce it different. Geometry works. Are you gonna have the problem with like part of the solution, or is it still just like reading it for yourself, or I guess like what's up? So the function is always positive. The derivative isn't necessarily positive though. The area should be positive. Maybe you make the claim, oh, it comes from this relating to that inequality. Okay. I guess that's fair. Suppose by way of contradiction that r is less than pi over 2, and cosine of x is greater than 0 for x from 0 to r. Aren't we already contradicting ourselves? Oh wait, no, we're not. I know this is already a contradiction, but no, we're certainly not. Cosine x is greater than 0. So you multiply this inequality through by cosine x, which I guess, yeah, I mean, it's still true. Left-hand side is the derivative of f of x cosine x plus f of x sine x. Is it? There's some product rule shenanigans happening in there, which I guess it probably works out. Yeah, you get a cancellation. All right, I don't have to like it. I do have to accept it, though, I think. How do you notice that, dude? Like, I would have tried to apply, like, figure out if there was a little product rule, failed because it's not. You'd be like, okay, I guess it's not the answer. Integrating from x equals y to x equals r. I assume y is, yeah, y is just 0 to r. Or r itself, strangely. What is this? Multiplying it through by secant squared? I wouldn't call that rearranging, but okay. I think 3 pi over 2 Well, no, I mean, so first off, pi over 2 is less than 3 pi over 2, and the question is asking for the least number. So if we can already accept pi over 2, 3 pi over 2 is never going to work. But 3 pi over 2, I think it breaks the, like, oh wait, I need to look at the problem statement. No, I guess 3 pi over 2 does satisfy all the properties. It's just not the smallest one. Yeah. So you'd say it's any positive 0 of this cosine function. Oops, sorry, this cosine function. Wait. Yeah. But you only care the smallest one anyway. Okay. That's kind of crazy. Wait. Or hours if you fall asleep. So yeah, Amorphous, does that, I guess, help you out for this problem? I would never in a million years be able to do this on my own, but at 4 a.m.? Oh, jeez. I guess we're both cooked. Yeah, like, there's a couple of steps in here that are incredibly hard to spot. Like this step here, like just like the steps of noticing that things are the derivative of other things is, and knowing to integrate it is a lot. Solution 2, there's a bunch of things that are you create it out of thin air. Like it's a really creative solution. So if things seem like they're coming out of nowhere, it's because they are. So go brush your teeth before anyone notices. Honestly, I don't really fall asleep during the day. Like I just can't really take naps for the most part. And when I have taken naps, I always feel worse after. Yeah, I think I'd be able to understand solution 2 and probably explain it to you, but it's just really creative, I guess. It's very hard to do this on your own on a timer. Because a naval officer, anywhere, anytime, just point to a cot. Oh, nice. I mean, that sounds kind of nice to be able to do. Can any of the math streamers explain it? I mean, I don't think there's any people who are going for math right now. Like, I can explain the steps here to you if there's a step that you're confused on. I couldn't get these on my own. But if you have a question about any one of the steps here, I think I can figure it out and tell you what's happening in it. Just if you give me the problem blind in a piece of paper, I wouldn't be able to do it, but I can understand and explain the solution to you if there's a part you have a question on. When your internal battery extremely low all the time. Oh yeah, I guess that'll help. Marissa, I'm probably gonna wrap up the stream soon, so if you don't like have something you want to ask me specifically, I think like a lot of the other math streamers will be able to explain it, but I don't think any of them are going right now. The thing from X equals Y. Okay. So let me, before I end the stream, we'll take a harder look at this. Any better reasonable? 1:45 a.m. All right, see ya, Obi. Thanks again for the raid. So yeah, we can draw this step out a little bit more. Y is just an arbitrary number. It doesn't mean anything that special. It's basically just a placeholder value. So we start with f prime x cosine x plus big F cosine x greater than or equal to 0, right? And so we notice that if you derive f of x cosine x plus big F of x sine x you do the product rule on each of these two things, you get cancellations. It's going to equal that exact thing. And that's helpful because we're going to do so we know what this thing integrates to. So this is a function in terms of x. So if we integrate just from some arbitrary point y out to the endpoint r, f prime x cosine x plus f cosine x dx, where y is from, is y 0 to r? X, okay, it's 0 to r. Y is basically just another version of x. We just don't want to like repeat x twice inside the integrand in the bounds. Because we know if you take the derivative of this, you get that. Our answer to the integral is going to be this thing on the inside. Yeah. Actually, I guess maybe I should say y is really just a placeholder for r. Like y is just a number between 0 and r. X is just a number between 0 and r. Whatever you want. They switched to using y because we just don't want to, it's bad form to reuse the variable inside the integral and a bound of integration. So you get f of r cosine r plus f of r sine r minus y cosine y. Okay. So that's what you get for the integral. Now, how do they work out this inequality part? Oh. So they're dropping off this f of r cosine r term. How do we get the inequality out of this, though? I'm not quite sure how they get the inequality now that I look at it in the next step. So, like, I'm trying to figure out how they got to here from where I'm at. And that's not so clear to me. It must have something to do with like one of these previous inequalities. It matches the forms somehow. Okay, you know what? I said I could understand and explain this to you. I can't understand this part though. Now that I look at it more. I can't immediately understand it at least. So yeah, I'm sorry, Marissa, I'm not sure what to tell you about the rest of that then. You give up on the problem? Okay. I think I'm gonna wrap things up for the day. It's getting harder for me to think now, so. Thanks for the question, but that's about as much as I can do with it, unfortunately. So yeah, let's wrap things up. I'm gonna cut the YouTube stream off here, so Amorphous, and if anyone else is here on YouTube, I appreciate you. I'll be back doing more math on Thursday. And hope you have a good one too, Amorphous. All right. Goodbye, YouTube.